You hear it all the time, right? That AI's potential is just limitless. This Cambrian explosion of intelligence that's going to change everything. But what if that's just not true? Today, we're diving into the hard, physical limits that could stop the AI revolution dead in its tracks.
The big dream, the one that totally dominates the headlines, is artificial general intelligence, AGI. You know, the idea of an AI that can learn and adapt to pretty much any task, just like a human can. It's a really powerful and honestly, an exciting concept. But it might be running up against a wall it just can't think its way around.
Because what if that whole dream just ignores a fundamental truth? This isn't just a software problem. The very laws of physics might be the ultimate barrier to creating this kind of infinite intelligence.
Okay, let's get into this because there's a really sobering perspective that's starting to gain a lot of traction among researchers.
So a scientist from the Allen Institute for AI is basically arguing that the entire conversation we're having about AGI is fundamentally flawed. Why? Because you can't just pretend the physical world doesn't exist. Every single calculation, every little bit of data that gets processed, it all happens on real hardware, here, in the real world. And that hardware? Well, it has hard limits. We're talking about mind-boggling energy consumption, the very real problem of getting rid of all that heat, having only so much memory, and the simple fact that hardware wears out. These are real-world constraints you just can't solve with clever code alone. So, here's the crucial point. When resources are finite, what do you get? Competition. These physical limits are dragging the AI race out of the lab and straight into the world of geopolitics and economics.
And it turns out that competition is now centered on one of the most basic resources you could possibly imagine: electricity. In fact, it's gotten so serious that tech leaders in the US have started using this really powerful term, the electron gap, to describe a brand new front in the global competition, especially with China.
Now, this is where it gets really interesting. Take a look at this. You can see China is using its huge, state-controlled power grid, especially in places like Inner Mongolia, to churn out tons of low-cost electricity. This gives their companies a massive cost advantage when they're training these enormous, power-guzzling AI models. So, let's just nail down what this term means. The electron gap is this idea that the main bottleneck for AI dominance is changing. It's not just about who has the fanciest chips anymore, it's about who has the cheapest and most plentiful power to actually run them.
Okay, let's keep going and see how this all spills over into the corporate world. Because these physical and economic pressures are creating this massive split in how companies are thinking about AI.
An investor named Gavin Baker breaks it down into two camps. On one side, you have the incumbents, the big established software companies. They're being cautious, just sort of layering AI features on top of their old products to protect the money they're already making. But on the other side, you've got the AI natives. These are startups building their entire companies around AI from day one, and they're completely redesigning how work gets done.
Baker actually has a name for what the incumbents are doing, the SaaS misstep. And it looks kind of like this. You take your old successful product, you bolt on a chatbot, you jack up the price, but, and this is the key, you never actually change how the user works. It's a strategy that many believe completely misses the real transformative power of AI.
But while all these huge strategic battles are being fought over business models, there's a much quieter, more foundational revolution happening behind the scenes to solve a really practical problem. And it all comes down to this one tricky question. As AI models become agents, things that can actually take actions for you, like booking a flight or ordering your groceries, how do you let them safely connect with all the external tools, websites, and data out there? You need a common language, right? A kind of universal adapter.
And this just brilliantly shows you the journey of that solution. It started as this small side project at Anthropic called the Model Context Protocol, or MCP. Then it was quietly adopted by the major AI labs. And now, it's becoming an open standard run by the Linux Foundation. It's basically creating the rules of the road for how these AI agents can safely play with the outside world. It's the unglamorous but absolutely essential plumbing for the entire future of AI. So, let's bring all these threads together. We've got physical limits creating an energy race, and that's reshaping corporate strategy. So how is all this redrawing the global map for where the money flows? Well, this is where things get really complicated. Even as you have politicians in the US pushing to cut off money flowing into China's tech sector for national security reasons, Wall Street is looking at China's advantages, like all that cheap power, and they're seeing a huge opportunity.
And the numbers, they're pretty stark.
over just the past year, American investment in Chinese AI-related stocks and funds has actually gone up by 32%. This just shows you the powerful tension between political goals and the simple financial incentive to chase growth wherever you can find it.
So what's the bottom line here? What are we supposed to take away from all this? First, AI progress isn't some abstract thing happening in the cloud. It's grounded in the messy reality of physics and economics. Second, the next big leap forward might not come from a brilliant new algorithm, but from a cheaper power plant. And finally, the quiet, boring work of building standards and new business models is every bit as important as the race to build the biggest AI model.
Which leaves us with a fascinating question for the future. For years, the bottleneck was silicon chips. Now, it's becoming electricity. As we keep pushing these boundaries, what's going to be the next law of physics that puts a ceiling on AI's ambition? Heat? Bandwidth? Or maybe something we haven't even thought of yet? The race is on.